Therefore, I see that I can apply SSS congruency for triangles ABC and DPQ such that the side AB is equal to DP as already assumed in the construction, and side AC is equal to side DQ also assumed in the construction, and it recently proved that BC is equal to PQ, which has been proved using the basic proportionality theorem and the given condition. We have BC equals PQ. Therefore, by triple S congruency, we can say that triangle ABC is congruent to triangle DPQ using the SSS congruency, the sides equal to the sides of the other triangle. Because the two triangles are congruent, we have the respective angles also equal. That implies angle A is equal to angle D, and angle B is equal to angle P, and angle C is equal to angle Q, because the congruency implies the respective angles are also equal based on the congruency. But already we have proved that angle P is equal to angle E by corresponding angles. Therefore, angle Q equal to angle F. Therefore, when I compare this with this, I understand that angle B is equal to angle P, which in turn is equal to angle E. Therefore, angle B is equal to angle E. Therefore, angle A equals angle D is one property which I identify. Then angle B is equal to angle E because both are equal to angle P. So angle B is equal to angle E, and similarly angle C equal to angle Q, and angle Q equal to angle F implies angle C is equal to angle F, transitivity. Therefore, angle C equals angle F. Now, when I see all these three angles equal, I clearly see that these are the corresponding angles of the two triangles which are equal, such that angle A equals angle D, angle B equals angle E, angle C equals angle F. That implies corresponding angles of triangle ABC and triangle DEF are equal. The corresponding angles of both the triangles are equal. Therefore, the two triangles, therefore, triangle ABC is similar to triangle DEF is what we prove using the SSS criterion for similarity of triangles, is how we understand through the proof. And it is nothing but the converse of AAA criterion, which I have seen in the previous case. So therefore, my learning outcome in case of the AAA criterion and SSS criterion is that in case of these two cases, I have corresponding angles equal implies corresponding sides in same proportion is what I conclude. So corresponding equal angles equal implies corresponding sides in same proportion, or the corresponding sides in same proportion implies the corresponding angles equal is what I identify, and hence for similarity of triangles the condition is restricted either to this or this, because one implies the other or this implies this, is what we conclude in similarity of triangles using the AAA criterion and SSS criterion. Now let's see the SAS criterion, the third criterion for similarity of triangles. So SAS criterion. Now let's see the statement of SAS criterion for similarity of triangles. Start with SAS criterion and its statement. So SAS stands for side angle side. We understand that one of the angle, corresponding angle, is equal and the two of the sides are in same proportion. Then we say the two triangles are similar. So let's see the statement in brief. If one angle of a triangle is equal to one angle of the other triangle and the sides which include the angle between the sides, the included angle, so and the sides which include that equal angle divides in same proportion or are in same proportion then we say the two triangles are similar. Then the two triangles are similar is how we understand the SAS criterion. To be more clear, if I take a triangle ABC and I take a triangle DEF, then I say that the two triangles are similar if one of the angle is same and the sides AB by DE is equal to AC by DF, these two sides being the included sides of the angles which are included here. So these two sides include the angle and hence AB by DE is equal to AC by DF is what is given here. So under these conditions we can say that the two triangles are similar. Therefore let's start with the given condition where I take the two triangles ABC and DEF such that one of the angle is equal. Therefore here it is given that angle A is equal to angle D and the sides including the angle are in same proportion, that is AB is the side which includes angle A and DE is the side which includes angle D. So AB by DE is equal to AC by DF. Is what is given. Now next comes the construction what I need to make for this. So the construction here is as similar as we have taken for all the three criterion, where P is a point on DE such that this equals this and Q is a point on DF such that this length AC equals DQ. Then immediately I join P and Q is what we have done for the previous criterion SSS criterion. So the proof of this is as similar as SSS criterion with only a minor difference in the last few steps. So in comparison to the triple S criterion, I clearly have the construction as let P be a point on DF such that DP equals AB and let Q be a point on DF, this is DE, and Q be a point on DF such that DQ is nothing but AC is what is the construction. Then finally I join PQ because I want the triangle DPQ to be considered in my proof. This is how I understand the construction part. To be continued with the proof of SAS criterion. Now to continue with the proof of Sas criterion I have here, let me consider my angle A is equal to angle D. So here, because P and Q are the points on this such that I have AB equals to DP and AC equals to DQ and angle A equal to angle D, I clearly have here from triangle ABC and triangle DPQ, I clearly have AB equals to DP. This is clearly from the construction which we have taken, since by construction I have AB equals DP. Similarly, AC equals DQ from the construction. So AC equals DQ similarly from the construction. And also angle A equal to angle D, because it is given in the condition of the statement. Therefore, angle A equals angle D, since it is given in the statement. Now, this makes me clearly understand that side angle side and side angle side are equal. Therefore, this applies to SAS congruency, side angle side. That implies triangle ABC is very much congruent to triangle DPQ by using SAS congruency, which can be applied for these two triangles. Now, when SAS congruency clearly shows that the respective angles and respective sides are equal, that is, I have this equal to this and this equal to this, because the three angles of congruent triangles are equal and the three sides are equal. That implies equals angle P, angle C equals angle Q, since by congruency property, which states that the congruency property which states that when two triangles are congruent, they are equal in all respects. They are equal in sides, equal in angles, equal in area, etc. Therefore, by congruency property, I can say that angle B equals angle P and angle C equals angle Q. Now, as it is given, also it is given that from the given condition, the corresponding sides are in same ratio, that is AB by DE is equal to AC by DF. So this is equal to AC by DF, which is strictly from the given condition, since this is given. So let me utilize this ratio, the proportional sides, in finding the proof for proving that PQ is parallel to EF. So this is used for proving this being parallel to this. So let's see how we can prove for PQ being parallel to EF using the condition as given in the statement. So therefore, considering the ratio AB by DE equals AC by DF, I have AB equal to DP. So in place of AB, I substitute DP, so that AB is replaced with DP by DE equals AC, which is equal to DQ, gets replaced with DQ by DF, since clearly I have AB equals DP and AC equals DQ from the given statement. Now this is clearly the basic proportionality theorem in its extension, because dP by dE equal to dQ by dF implies PQ is parallel to EF by the extension of basic proportionality theorem. Therefore, that implies PQ is parallel to EF, since by extension of basic proportionality theorem, I have this, which clearly makes me have this parallel to this. Now when two lines are parallel, their corresponding angles are equal is the property we have in parallel lines. Therefore this will be equal to this and this will be equal to this. Therefore PQ parallel to EF implies angle P is equal to angle E and angle Q equals angle F, since corresponding angles are equal in parallel lines. Therefore this equals this and this equals this is what we get for the corresponding angles. Now already we have proved angle B equals angle P and angle P equals angle E, therefore indirectly angle B equals angle E. Also, let me recap from the proof we had in proving from SAS congruency that angle B is equal to angle P and angle C equals angle Q. Therefore, when I compare this with this, I have angle B equals angle P and angle P equals angle E. Therefore, angle B equals angle E. When angle C equals angle Q and angle Q equals angle F, by transitivity, angle C equals angle F. So, let's continue with the proof followed with. Therefore, by transitivity, I can say angle B equals angle E and angle C equals angle F, since by transitive property, if A equals B, B equals C, then A equals C is what we know as transitive property. Therefore, this equals this. Therefore, finally, we have this from the given condition already that angle A equals angle D, and we have proved that angle B equals angle E, and also angle C equals angle F, which in turn is nothing but this implies corresponding angles are equal. That implies I can use the Sas criterion to show that the two triangles are similar. When corresponding angles are equal, that implies by AAA criterion, triangle ABC is said to be similar to triangle DEF, is how I conclude the similarity of two triangles by using Sas criterion for similarity of triangles, is how we understand through the proof. So let's see the similar triangles connected with areas. Now, areas of the triangles and the similarity of the triangles are very much associated, because as we see through different geometrical structures, we see that if I take two different triangles and find their areas, then the ratio of the areas is always the ratio of squares of their sides, the corresponding sides. That is, if I say the statement which says that for two similar triangles, the ratio of their areas, is equal to the ratio of the squares of their corresponding sides, is equal to the ratio of the squares sides of the is equal to the ratio of the squares of the corresponding sides of the triangle which are corresponding to each other. That is, if I take a triangle ABC and a triangle DEF, then I have these two triangles to be with the ratio with areas, say area of triangle ABC and area of triangle DEF, is equal to square of their corresponding sides in same ratio of the squares of sides of the triangle, that is AB squared by DE whole square, or AB squared by DE squared will be equal to BC by EF whole square, which is equal to AC by DF whole square, AC by DF whole square, which we get in as the statement of this areas of similar triangles. That is, if I know the ratios of the corresponding sides, or if I know the scale factor of the triangle, then I can find the areas of the triangles respectively. If I know one area of the triangle and the scale factor, I can find the area of the other triangle based on the scale factor. Or if I know the areas of the triangles and the scale factor, then I can find the dimensions of one of the side through the areas of triangles, is how it is connected. So this is the statement of the theorem. So let's see the proof of the given theorem. So let's take the given part of the statement which we have taken for proving for areas of similar triangles connected with their corresponding sides. So it is given that triangle ABC, let me say the triangle ABC is similar to triangle PQR, so that when I take the two triangles, this is ABC and this is PQR. So triangle ABC and PQR are the two triangles which are similar, that is, this is similar to this. Now using this, we have to prove, it is required to prove that area of triangle ABC by area of triangle PQR is square of their sides in corresponding sides in ratio, that is AB by PQ whole square is BC by QR whole square that is equal to AC by PR whole square, that is AC by PR whole square is what I need to prove in this proof of the theorem. Now my construction here is that I draw a perpendicular from A, which is M, and I drop a perpendicular from P, which is N. Therefore, AM and PN are perpendiculars on BC and QR respectively. Therefore, let AM be perpendicular to BC and PN be perpendicular to QR is what we understand in the perpendicular concept of two triangles. Now using this, let's find the proof of finding the areas connected with sides. So to continue with the proof, so let's see the proof of the theorem. Now here, because the triangles ABC and PQR are similar to each other, let's consider the area of triangle ABC by area of triangle PQR. Now we know that area of triangle is half into base into height. Therefore, area of triangle ABC is half times base assumed as BC and its height is the perpendicular AM. Therefore, clearly I have this with the formula half times base into height, which is AM. And then for triangle PQR, I have the base as QR and the height as PN. Therefore, this reduces to half times base into height, which is this. Now when I cancel half on both sides, I get this as BC times AM by QR times PN, which I get as equation 1. So area of triangle ABC by area of triangle PQR is finally simplified to be this, which I take as equation 1. Next, I consider the triangles. First, I consider triangle ABM and AQN, which are right angled triangles. So, the triangle ABM and triangle PQN, which are right angled triangles. And let's see if those two triangles are similar. Now, in this case, angle B is equal to angle Q because the two triangles are similar. Therefore, here I have angle B equals angle Q in these two triangles, and angle BMA or AMB is equal to PNQ because both are 90 degrees. So angle AMB is equal to angle PNQ, which is 90 degrees. Now this angle B is equal to angle Q because since by AAA similarity of two triangles, I have one of the angle equal to the corresponding angle of the other triangle. Now this is equal to this because both are 90. Therefore, these two imply by AAA criterion, we have already simplified that to be with AA criterion. By AA criterion for similarity, I can say that triangle ABM is similar to triangle PQN because these two triangles are similar by AA similarity. If two angles of one triangle are correspondingly equal to the two angles of other triangle, we have already proved that the two triangles will be similar by AA criterion for similarity. Therefore, this triangle ABM, which we have considered, is similar to triangle PQN, is what we get from similarity. So to continue with the proof. Therefore, the triangle ABM similar to triangle PQN implies that the corresponding sides are in same ratio, because when two triangles are similar, their corresponding angles are equal and the corresponding sides are in same ratio. So for the corresponding sides being in same ratio, AB by PQ will be equal to AM by PN equal to BM by QN. Therefore, that implies AB by PQ will be equal to AM by PN, and finally BN by QN, which are also equal by definition of similarity. So by definition of similarity, I can say that the corresponding sides are in same ratio for the two triangles ABM and PQN. Now next, I will consider the triangles ABC and PQR. So I take the whole triangle. So from triangles ABC and triangle PQR, let's see what will be assumed from similarity. Now we already have taken from the given concept that ABC is similar to PQR. This similarity shows that the corresponding sides are in same ratio. Triangle ABC is similar to triangle PQR since it is given. Therefore, I have the corresponding sides in same ratio, that is AB by PQ will be equal to AC by PR, which is equal to BC by QR, is what I get, since by definition of similarity. Is what I get. Now, as I compare this equation 1 with equation 2, I see that from these two equations, AB by PQ and AB by PQ are equal. So therefore, from equation 1 and 2, I understand that my BM by QN is AB by PQ and BC by QR is AB by PQ, as can be seen from 1 and 2. Therefore, from 1 and 2, I have BM by QN, which is equal to AB by PQ, which is in turn equal to BC. So this will be equal to AB by PQ, which is equal to BC by QR. Therefore, I get BM by QN equal to BC by QR equal to AB by PQ, which I substitute in the area of triangle which I have obtained in the starting. So let's substitute this in the area of triangles taken in the ratio and see what we get. Continue.